Hi, today we're solving problem 42. The nth term of the sequence of triangle numbers is given by t sub n is equal to 1/2 n times n plus 1. So the first 10 triangle numbers are, and we are given these numbers, 1, 3, 6, 10, 15, and so on. By converting each letter in a word to a number corresponding to its alphabetical position and adding these values, we form a word value. For example, the word value for sky is 19 plus 11 plus 25, which is equal to 55. And this is also the 10th triangular number. If the word value is a triangle number, then we shall call the word a triangle word. They've given us a file words.txt, and it contains nearly 2,000 common English words. We need to find how many of these are triangle words. So let's go ahead and switch over to IntelliJ. The first thing I'm going to do is parse out all of these words. So you can see that they're all in one line, and there are commas in between, and they're surrounded by quotes. So we've done parsing like this before. All we do is create a val words is equal to source dot from file. Let me import scala.io.source to read the file. We give the file name, which is p042 underscore words.txt. We get all of the lines and get the first line because all of the words are on one line. Then we're going to split this line on every comma. And for each of these words, we see here that we have quotes surrounding them. So to knock out the first and last elements, we just take the quoted string and do .tail .init. And we can convert this to a list. So now we have all of our words. Now we need to be able to figure out the word sum, so the word value here. So we can create a def word value, takes a word of type string. Here what we're going to do is we're going to iterate over every character in word, and we're going to map the value. So we take the character. We need to find how far away from A is the character, and we see here that they're all capital letters. So we're going to do the character minus capital A, and this gives us how far away it is. And we need to add 1 because we have 1-based values. So for example, when C itself is A, this should return us 1. So that's why we're adding this 1 here. Now we just sum up these values, and that gives us the word value. Now the last thing is calculating the answer. We're going to filter on words. We're going to take each word. The first thing we're going to do is calculate the value. So you can do val value is equal to word value for that word. And now we need to detect if this value is a triangular number. Now how do we do that? If we go here, we can see the formula for a triangular number. And this formula is so because each triangular number is just the sum of 1 to n for the nth triangular number. So sum of all the numbers from 1 to n. So here we just do n times n plus 1 divided by 2. Now, if it is a triangular number, if we calculate the square root of doubles, so here if we move this 1/2 to the other side, so that'll give us double our triangular number is n times n plus 1. And we know that n has to be an integer, so if a given number is a triangular number, then double that number, and then if we calculate the square root, that should give us a value between n and n plus 1. And again, since n and n plus 1 are integers, we can then round down that square root, which is between n and n plus 1, and then we can check if this value for that floor of the square root is equal to double the value. So what I'm going to do here, I'm going to calculate a val root. We're going to do math.square root of the value, and we're going to convert this to an int to get to the floor. So for example, of something with 55, actually we don't want to do with value, we want to do value times 2. Because we know that 55 is 1 is going to be 10 times 10 plus 1, which is 11, divided by 2, which is 55. So what we can do is, we know that n times n plus 1, for the case of 55, would be 110. We calculate the square root of that, and we know that is between n and n plus 1. So then we can, and we know that n and n plus 1 are the closest integers to that square root. So then we can just calculate these values. So here this gives us a value of n root. Now all we have to do is check that the root times the root plus 1, so this is n times n plus 1, is equal to the value times 2. And that's all we have to do to check. So now we can print an answer, and this would give us all of the words that work. We can run this, and this gives us all of the words that work. And we can actually see that sky is in this list. And sky's word value is the 10th triangular number. But we don't care about which ones are triangular words, we just care about how many. So we just replace filter with count, and that'll give us how many. We can run, and we get our answer, 162. So that's it for problem 42. I'll see you next time when we solve problem 43.